All right, let's deep dive into these titans. They're these large language models causing a stir, and I think for good reason. Everyone's talking about how they're tackling that quadratic cost problem, that thing that's been haunting traditional transformers. It's where the resource demands just explode as your input sequences get longer and longer. A real roadblock for anyone who's working with massive data sets.
Yeah, exactly. It's been a huge problem, like trying to run a marathon with a backpack full of rocks. You just can't keep up.
Mhm.
But Titans seem to have found a way around this, and it's a pretty ingenious approach, I think.
Okay, so let's get into it. What makes titans different? How are they tackling this computational beast?
Well, the magic is really in their architecture. They've incorporated this thing called a deep neural long-term memory module, which is essentially like giving the model a separate specialized memory bank.
A memory bank, huh? So how does that help with the quadratic cost problem?
Okay, so think of it this way. Instead of processing the entire input sequence every single time, which is what traditional transformers do, Titans can just pick and choose. They can retrieve and use only the most relevant information from their memory. It's like having a personal assistant who can instantly pull up the exact files you need, but from a massive archive.
So it's all about efficiency, just focusing on what matters instead of crunching through absolutely everything.
Exactly. And this targeted retrieval, it really helps to cut down the computational load, especially when you're dealing with those super long sequences that would bring a traditional transformer to its knees.
I'm starting to see the picture here.
Sure.
But how do they decide what's essential? How does this memory bank know what to keep and what to just toss out?
That's where it gets really interesting. Titans use this dynamic key value retrieval mechanism.
Okay.
You can kind of think of it like a really sophisticated indexing system. Every piece of information gets assigned a key, which is like a unique ID and a value which represents the actual information.
So almost like a massive library where each book has a specific call number.
Exactly. So when the model needs to access a certain piece of information, it uses the key to quickly locate and retrieve the corresponding value from memory. Really makes the whole retrieval process as efficient and targeted as possible.
This key value system sounds really clever.
Mm.
But I'm kind of curious about how those keys and values are determined. Is it like some predefined rules, or is there some kind of learning going on?
That's a great question. The really cool thing about Titans is that they actually learn. They learn which keys and values are the most important during training. So they're not just relying on some static, handcrafted system.
So the model is basically figuring out its own filing system for memory, just based on the data it's been trained on. That's pretty impressive.
It is, and it's one of the key things. It's one of the key factors that allow Titans to perform so well on those long-range dependencies. They're not just storing information, they're learning how to organize it and access it, all in a way that's tailored for the specific task at hand.
Right, that makes sense. But you mentioned test time memorization mechanics earlier. What exactly happens during that test phase? Is the model still learning? Is it still updating its memory bank?
That's a really common misunderstanding. During testing, the memory bank is essentially frozen in time. The model can pull information from it, but it can't add anything new or change what's already there. Kind of like studying for an exam. Once the exam starts, you're stuck with what you've learned. No more cramming allowed.
Okay. So it's all about putting the model's memory to the test, seeing if it can actually apply what it's learned to new situations.
Exactly. And the results have been impressive. In all kinds of benchmarks, Titans have shown that they can remember really specific details, even from super long sequences of information. And they often beat traditional transformers by a pretty wide margin.
So it's not just theoretical, they're actually delivering the goods. This is starting to sound like a real breakthrough for dealing with those really long sequences.
It definitely has the potential. The key now is to see how these models scale and how they do on even more complex and even more diverse tasks.
This brings up another point. How efficient are Titans compared to existing models? Are we really saving computational resources, or is this just some kind of trade-off?
Well, the research is showing that Titans really do offer some big computational advantages, especially when you compare them to traditional transformers. They've shown some significant reductions in FLOPs, that measure of computational complexity, and it's especially true when they're dealing with those long sequences.
So they're not just faster, they're actually doing more with less. But I'm guessing it can't all be perfect. There have to be some limitations or some trade-offs, right?
Of course, there are always going to be trade-offs anytime you have a complex system. And one of the big ones with Titans is memory overhead. Remember, we're talking about storing huge amounts of information in that memory bank. And that can put a strain on your resources. especially as the sequences get longer and that memory bank starts to really balloon.
So like having a super spacious warehouse, but maybe struggling to keep everything organized and accessible. Are there ways to like mitigate that memory overhead?
Oh, absolutely. Researchers are looking at all kinds of ways to optimize how the memory is managed in these titans. One promising idea is to selectively prune the memory bank, getting rid of information that's just not as important. It's like decluttering your closet, get rid of the things you don't really need to free up space.
Makes sense. But how do they decide what to keep and what to toss? Seems like a tricky balancing act.
It is, for sure. They're using these sophisticated algorithms to analyze, to figure out the relevance and importance of each piece of information, but always within the context of whatever the task is. So it's not a one-time purge, it's like a constant optimization process.
That's pretty neat. But how does this whole memory-centric approach compare to some of the other efficiency techniques out there,
Sure.
like those hybrid models that combine transformers with linear components?
Great question.
Have you looked into those at all?
Yeah, there's been a lot of research into those hybrid architectures, trying to get that perfect balance between the expressive power of the transformer and the efficiency of linear models. And they've shown some good results too. But Titans, they offer something totally different. Instead of tweaking the core transformer architecture, they've added this whole new memory component. It works alongside everything else.
So less like tinkering with the engine and more like adding a turbocharger.
I like that analogy. And the early results, those benchmarks, suggest that this turbocharged approach, it might actually be even more efficient than those hybrid models, especially when we're talking about those really, really long sequences.
Okay, so Titans seem to be ahead in the efficiency game. But I'm sure there are still situations where they might not be the best tool for the job. What are some of their limitations? Are there any scenarios where you'd maybe choose a different approach?
Yeah, you're right. It's not like Titans are some kind of silver bullet. For example, if your task involves real-time processing, where you need super quick responses, Titans might not be the best fit. Remember, these models, they like to take their time, dig deep into these long sequences.
Yeah, so they're not going to replace every other model out there overnight. There's still a need for models that are built for speed.
Exactly. You always got to pick the right tool for the job. If you're analyzing huge data sets, trying to find complex insights, Titans are a great option. But if you need a lightning-fast response, a different kind of architecture might be better.
Okay, that makes sense. But I keep thinking about this. Titans seem to blur the lines between traditional AI and something that feels almost human. This ability to remember things, to prioritize information. It's like they're developing some kind of cognitive sophistication.
It's interesting, isn't it? It's a thought that a lot of researchers have been having too. This whole idea of adding long-term memory into these models. It really raises some deep questions about what intelligence actually is. Are we just copying human thought processes? Or are we maybe tapping into something more fundamental, something that goes beyond the differences between biological and artificial systems?
Yeah, that's a deep rabbit hole. We could probably talk about that for hours. But I think it just highlights how transformative Titans could be. They're not just making things faster, they're changing how we understand AI.
I agree. And as these models get more advanced and more complex, those questions are just going to get more and more important.
For sure, we're at the beginning of a whole new era for AI. And we need to be thinking carefully, not just about how to make things faster, but about what it all means for society, the ethical side of things.
Absolutely. We can't just chase performance gains without considering the consequences.
Right. But let's switch gears a little bit. Let's talk about some real-world uses for Titans. You mentioned earlier that they're really good at tasks that involve long-range dependencies. Can you give us some examples of what that might look like in practice?
Sure. One area where they're showing a lot of promise is in natural language understanding. So things like summarizing documents, answering questions, even creative writing. These are tasks that require the model to really get the relationships between things, not just words or sentences, but ideas across long chunks of text.
So it's not just about remembering facts. It's about understanding the nuances of language, how ideas flow, what the story is, almost like they're developing some kind of reading comprehension.
That's a great way to put it. And Titans are turning out to be really good at it. For example, they've gotten state-of-the-art results on benchmarks like the BABI tasks, which are designed to test how well a model can reason about complex narratives, like keeping track of relationships between characters and events and stuff.
Wow, so we're now at a point where AI systems can not only understand but also reason about stories. It opens up so many possibilities, not just for research, but for practical applications too.
Totally. Imagine AI that can help us analyze historical documents, extract key insights from scientific papers, or even write compelling and creative stories. There's so much potential there.
This is all really exciting. But I do have to ask, are there any tasks or areas where Titans might not be the best solution, even with their impressive memory abilities?
Well, like we talked about before, tasks that need super fast processing, those might not be the best fit for Titans. But there are other things to consider too. Like while Titans are great with sequential data like text or time series, they might not be as good at handling data that's structured differently, or data that comes from multiple sources.
So like image recognition or video analysis might not be their strong suit.
Exactly. Those kinds of tasks often need different architectures and algorithms, ones that are built specifically for those types of data.
Okay, so it's not a one-size-fits-all kind of thing. It's about knowing the strengths and weaknesses of each tool in your AI toolbox.
Exactly. And I think that's a key takeaway here. The world of AI is becoming more diverse, more specialized. It's not about having one super powerful AI that can do it all. It's about having a whole ecosystem of specialized models, each with their own strengths and weaknesses.
Like building a toolkit for the future of intelligence. And Titans, with their amazing memory capabilities, are definitely a valuable tool to have. But before we finish up this fascinating conversation, I want to come back to something you mentioned earlier, the ethical implications of all these advancements. We're talking about AI that can remember and reason over massive amounts of information. That raises some serious questions about privacy, about bias, and about the possibility of misuse.
You're absolutely right. As these models get more sophisticated and more integrated into our lives, we really need to be paying attention to those ethical considerations. Like, how do we make sure these models aren't perpetuating existing biases or discriminating against certain groups of people?
Yeah.
How do we protect the privacy of the people whose data is being used to train and test these models? These are tough questions that need careful thought and open discussion.
Yeah, it really feels like we're entering uncharted territory, where all these incredible technical advancements are making us face these really big ethical questions. It's like a reminder that progress isn't just about doing new things, it's about understanding what those things mean for everyone.
Yeah, exactly. It's not enough to just push the boundaries. We have to think about the impact, too. We need to make sure that these powerful tools are used for good. And that means we need to have these conversations. Researchers, policymakers, the public, we all need to be involved.
So it's not just a technical challenge, it's a challenge for society as a whole. It feels like we're at a really important moment. The decisions we're making now about AI, they're going to shape our future. But let's get back to the technical side for a minute. What do you think the future holds for Titans? Are there any research directions that you're particularly excited about?
Oh, yeah. There's so much exciting research happening right now. One thing that people are really focused on is trying to make Titans even more efficient. Remember, we talked about that memory overhead problem?
Yeah.
Well, researchers are working on some really clever ways to manage that memory better. Things like dynamic memory allocation, compression algorithms, trying to squeeze even more performance out of these models while using less resources.
So it's like trying to find that sweet spot between power and efficiency, making sure they have enough memory to do all these amazing things, but without becoming too resource intensive.
Right, exactly.
Are there any other research areas that you find particularly interesting?
Another area that I think is really fascinating is this idea of combining Titans with other AI techniques. Like some people are experimenting with integrating them with reinforcement learning algorithms.
Oh, wow.
So you could have AI systems that can not only remember things, but they can also learn and adapt their behavior based on their experiences.
So they can learn from their mistakes and get better over time.
Yeah, that's the idea. It's like they're developing a kind of artificial wisdom.
That's incredible.
It really shows you the potential of these memory augmented models. They're not just improving performance, they're changing the way we think about intelligent systems.
It sounds like we're on the verge of a real paradigm shift in AI, moving away from those narrow task-specific models and towards something that's more general purpose, more adaptable, just more intelligent overall.
It's definitely an exciting time to be working in this field, and Titans are right at the forefront of this whole revolution. They're making us question what AI can do and what intelligence really is.
Well, I think it's safe to say that Titans have definitely lived up to their name. They're shaking things up in the world of AI and leaving us with a lot to think about. But I think that's a good thing. It means we're on the right track, pushing the boundaries of knowledge and exploring the unknown.
Absolutely. The journey is just beginning, and I can't wait to see where it takes us.
And on that note, I think we'll wrap up our deep dive into the fascinating world of Titans. Thanks for joining us, and as always, stay curious.